Hey everyone, it's Adriana and welcome back to another video. This is going to be the final reflection video for data structures and algorithms, talking about the final labs for this class, Lab 7 and Lab 8. Let's get started. Lab 7 was on binary search trees and Lab 8 was on the Huffman Compression algorithm. Both of these labs I struggled with a lot, but between the two, the final lab, the Huffman Compression algorithm lab, that one by far was the most difficult. It took me the whole week to get it done, and I was so frustrated with it. I was at a point of, I wasn't sure I was going to be able to figure it out, but I did, thankfully, and I will get to that in a second. For Lab 7, the binary search tree lab. This is one of the final data structures that is taught in this class, and a brief idea of what a binary search tree is. It's just a way to store information. It's similar to a linked list, but instead of having what a linked list has, which is nodes, a binary search tree has leaves, left or right, root that represents the top of the tree, and all that. The main difference between the linked list and a binary search tree is that while a linked list stores it from top to bottom, and there are a parent node with a parent always having to have two child nodes. And the very new topic for this lab was the hierarchical transversal algorithms and having to use that. And as far as the data members that were given, when it comes to the nodes, there was 4 of them: data, left, right, parent. And then for binary search tree wise, the M root, which represents the pointer to the root, which is the top node. And then the methods. In total, there were 14 methods. This lab took me several days to complete. I had some minor issues, but nowhere near as difficult as the final lab. For methods wise, node constructor, BST, binary search tree constructor, push method, clear method, destructor, contains method, find node, which was an optional method, but it actually came to be helpful for other methods, and I just ended up using it. And then there was several remove methods: remove case 0 method, remove case 1 method, and then remove case 2. And then all 3 of them remove case methods would be combined into the one remove method. And then the in order method, and then of course the assignment operator and the assignment constructor. The Huffman Compression lab, final lab, Lab 8. In particular, the Huffman compression algorithm is a lossless compression algorithm and is partially what the zip algorithm uses. It uses a frequency table to build a binary tree that is used to generate the encoded bit sequences, and it will compress data. And this lab used binary file input-output, binary trees, arrays, and vectors. A lot of stuff from previous classes. The new topics is having to utilize a priority queue from the C++ library, and then the bit F stream and the other stream classes, which that was just classes that the instructor made specifically for this lab. Data members. There was a lot. There was specifically for just the Huffman node. There was one for value, one for frequency, left, right, parent, to help build the Huffman binary search tree. And then Huffman, in particular, for the compression parts, there was the file name data member, one for frequency table that would hold the array, and it would have 256 unassigned values that would store the ACCI symbol numbers and symbols. And then leaf list, that will represent the vector that will hold the leaf nodes. And then root, pointer to top of tree. And then another table, that one specifically was for the encoding table, and that one's also an array of 256 vectors that contains booleans, and that would also hold an index of bit code that will need to be pulled from the file that was given for this class. And then the methods. In total, there was 9 methods. There was the Huffman constructor, the generate frequency table, generate leaf list, generate tree, clear tree, destructor, generate encoding table, compress, and decompress. In particular, I had a lot of issues with the compress and decompress methods. It took me several days to figure out what the heck I was doing wrong, and I was getting so many errors and so many fails instead of passes. But with the help of Discord and also watching the final lecture for this class that covered Huffman Compression, it did give me some clarity into what I should do to get it right and get the passes, and that's what I did. Because at first this lab seemed a bit too easy, and then as soon as I got to the final 2 methods, that's when everything kind of went downhill from there. If you struggle with having to utilize binary input-output, any of them types, having to read and write, you will struggle with this Huffman lab like I did. Looking back, my main tips, especially for these final 2 labs, is with the PDF file that has all the instructions on what to do for each lab. Read the PDF carefully. Read each of the instructions for each of the methods. Read them step by step. Read them a couple times, starting from the Huffman constructor and then all the way to the compress and decompress methods, which are the most difficult ones out of them all. Just take your time, and eventually you'll get it to work. That will be it for all these lab videos for this class, and hopefully I gave you some insight into what to expect for these labs. Thanks for tuning in. If you have any questions, you know what to do. Just message me and I'll get back to you. Thanks for tuning in, and I will see you guys in the next video, which will be for my next class, linear algebra. Thanks again. Bye.